what you're doing is the same thing that we do when we mount the solid rocket boosters. You're using a high tensile strength bolt, and you're stretching, and you're stretching, and you're stretching. You're actually stretching the bolt like silly putty, so that when that nut snaps, it's preloaded, it just blows right off. And so when we get in space, we use pyrotechnics, and it's a split nut, and all you do is put a couple of pyrotechnics, you blow it apart, and that's how you say goodbye to the external tank. Okay? So that's the external tank. Does anybody know much about Shuttle? Anybody know much about Shuttle? Anybody know much about orbiters? You know which orbiter this is?
Columbia?
It's distinct.
No, I don't know.
Who shouted out the Columbia?
Columbia.
Why? Why do you think this is Columbia? I'm going to let you cheat. I'll even let you see Endeavour. I was there the night we bought Endeavour from Rockwell International in 1991 at Plant 42 in Palmdale, California. I was there when we rolled it out. I was there when we piggybacked it and brought it back to Kennedy. There's three distinct ways to tell Columbia from the other vehicles. First, it was a test bed. It had an infrared camera in the tail. This is called the silts pod. On re-entry, it was the test bed. We wanted to see the hot spots that were just about right on the money. Just a little bit of tweaking. The front of the wings are painted black. See it? Where it meets the fuselage right here. What they call felt reusable surface. We're going to have a test on this. It's called frizzy. Felt reusable surface insulation. So the frizzy's painted black. This is the only configuration that flew USA. And that's Columbia hanging right in the transfer aisle. This circle right here is on the floor right over there. There's a bunch of stuff on top of it. So that's Columbia hanging right in the transfer aisle on the orbiter lifting fixture. You see that yellow fixture there. And here you see it right in the picture. So there are 4 main attach points. You hook up the 4 main attach points and you lift it up. Okay? This vehicle in this configuration weighs about roughly 200,000 pounds. We have 5 main cranes in this facility. We have our little baby crane, and that runs north and south. You can see the yellow rail, and that's 175 tons. That's our baby crane. Okay? We have 4 overhead cranes that run east and west. The biggest of those is 325 tons. So basically, folks, we can lift whatever the heck we want. Well, those cranes run in millimeters. You can set this crane hook, which is the size of me, on an egg and keep it there. They've done it before, just to test their abilities. Of course, that's the egg, side to side, right, is incredible, right? So they use that technology on Shuttle to produce what we call boron struts, or support struts in the wings. Those boron struts, I could take that strut, which is extremely expensive, and bend it on my knee, just like this. But the end-to-end pressure is incredible, just like an egg. And that's why we utilize that. This is what we call the entire stack. So this would have been in the high bay. This just happens to be the orbiter Endeavour. This is a 4-segment booster. So on the boosters, anytime you see black lines, that's a factory joint. Anytime you see white, that's a field joint. So that's where we put it together here. The black is factory, the white is field joints. So this is a 4-segment booster. So that's the entire stack. This vehicle produces about 6 million pounds of thrust at sea level. So for those of you that work a little bit with aerodynamics and aerospace, the thrust to weight ratio on this vehicle is very good compared to Apollo, which weighed about 7 million pounds and produced about 7.5. So once you sit it on the pad, you start those 5 main engines, you have to let it sit there to build up enough back pressure to leave the ground. That's how heavy that vehicle was. This has no problems. When those boosters fire, this thing jumps off the pad. Very quick. Okay, so this is the mobile launcher platform. This whole thing. I'm going to show you one. It weighs roughly 6 million pounds. And this is a platform that we build the space shuttle on. Okay? And then we actually pick the platform up and bring it to the pad and set it down. So we're carrying 10.5 million pounds to the launch pad on a crawler transporter. You want to see something impressive? That's impressive. All right, folks, another thing I want to share with you while you're in here. We recovered 39% of Columbia out in Texas, for the most part. Columbia, we're required, both Challenger and Columbia, you're required by law to keep those pieces, parts, that debris for 5 years. We still have both Challenger and Columbia. Columbia happens to be up on the 16th floor of this building, and that's why you see the flight insignia on the wall there of STS-107. Columbia's with us. Something that we did different from Columbia, that we did from Challenger. After the tragedy and we found out what happened, we went to the families. NASA actually approached the families and requested permission to use the pieces, parts for academia, for college and universities, to experiment with and develop new technologies, and the families were overwhelming yes.
Can you say that again?
Do that.
What did you say?
So what they've done is,
Sticker there and then what?
yeah, up above that yellow rail is a big room that holds the pieces, parts of Columbia. You can request online through the website pieces, parts of Columbia, and we will send it to you, college and universities, for you to do research with for a period of time, and then you send it back.
How much stuff did you get back?
We recovered 39%.